So this is the third time that I'm trying to record this. The first two times had footage where you could literally count individual pixels, which is why they're pretty much unusable. So here we go. Hello everyone. So Create added these chain conveyors behind me in the last update. And when I first saw them, I thought that they were a little bit overpowered, because they basically don't cost any brass, and they just remove any need for storage in the game whatsoever. I still think that they're very overpowered, but I also discovered a way that dealing with them can be fun, in a sort of programmatic, hey, I found a really cool thing to abuse to make these things do what they're not supposed to do kind of way. First of all, let me probably start with explaining what these actually do and why they're so cool. So, these chain conveyors here can work together with a couple of other new items, one of them being the frog port and the packager. And the way that that works is that basically the packager can package items into these cardboard boxes here. The frog will be able to automatically put the package onto the chain conveyor and take them out. So if I put the barrel in here, you can see it's packaged, the frog puts it on, the other frog takes it out. The way that the frog knows what package to take out is by putting a sign next to the packager. We can address every single package that it will send out. So if I try this again and grab the package, you can see that this package is addressed to storage. And if I put it on, this frog has the addressed storage, which means that it'll accept all packages addressed to storage. Yeah, this is cool so far, but where this gets really interesting is in combination with these stock links here. So what you can first do, that's why this fox is over here, you can probably hear it all in the background for a while. This fox here, because it's next to the stock taker, is a stock keeper. And basically what you can do is this stock taker is linked to the stock link over here, and it will transmit all of the contents of the vault to this inventory here. So this is basically, for those of you coming from Applied Energistics, this is the ME terminal of this system. And if I click on these items here, I can order them, and I can order them to be sent to depot. And I do that, you can see that the frog has put it on, and here's the depot frog, and that is now unloaded the barrels into this barrel here. That is the first part of actual use for this, and the second one is this panel over here, this factory gauge. This thing here, that I cannot pronounce, is able to designate sequences and addresses to craft items for you. Which, what that means is basically I have stripped oak logs and oak logs, and I can make more stripped oak logs using the oak logs. That's in here basically, one oak log turns into one stripped oak log if you send it to the saw. And the saw is this frog over here. And if I now go to the stock keeper and I say, hey, please give me all of the stripped logs, you can see that this arrow here has turned blue, and it's now sending logs to the saw to be sawed up. And it'll basically keep doing that until we have fulfilled our quota of stripped oak logs. Now, the part where this system kind of doesn't work anymore is when you want this saw to do multiple recipes. I have not set a filter in here, so that theoretically if I wanted to, say, saw a spruce log, I could just do that. But the problem with that is there are recipes that have multiple sawing outputs. For example, I believe you can make stairs using a saw, but that sawing recipe itself actually has multiple results. So you can see that all of these are created by oak plank, on a saw, but the results are different each time. And the way that you'd usually pick one item out of these is this filter here. So if I put some planks in here, you can see that this is pretty much making random stuff, but if I put the filter in here, it'll only make stairs. Andesite shafts are one of those items that have multiple recipes because they also make some other ingredients. And if I take all of the andesite shafts out of the network, you can see that it's trying to craft more. It's trying to craft 12 in total. And we've just made ladders because this isn't filtered, which means it's still expecting one shaft, so it doesn't send any more. You could say that promised items expire. 30 seconds of no more items, and then this just keeps sending new. But the problem with that is that you're still making all of this other stuff. So the andesite ladder, for example. And we just made another junk item, I'm pretty sure. Yep, we just made some andesite scaffolding. And this will basically burn through andesite until it randomly happens to craft the other shafts. Which, that's not good. We don't want that. We want to be able to target what item this here makes. And that is sort of the idea that I was trying to make into a reality. Basically, the ability to be able to send extra information within these packages. Not just ingredients for a crafting recipe, but also some instructions for the machine crafting on what exactly it should do with those ingredients, because there is multiple things that are similar to this. For example, most deploying recipes have two components to them. One of them is the thing that's in the deployer, and the other one that's being deployed onto. Or the fanning recipes have different blocks in front of the fan. These here, basically, there's 4 possible blocks that you can have in front of a fan. Each of those gives you different outcomes. So maybe you want to be able to control that just from the recipe. I'm actually going to stop these from timing out because it's just going to keep crafting until it has them. Like, it still hasn't made the other couple shafts, but it's made table cover, andesite ladder, andesite bars, and andesite scaffolding. So I think my point stands that this original system is not ideal. And we would really like to be able to send some extra information to the saw to say, hey, I know you have multiple possibilities, but this andesite alloy comes to you with the intent of eventually turning into a shaft. And I found 2 ways to do this. One of them is more practical, and the other one is very esoteric, but as a programmer, it makes me very happy. So I'm going to spend more time on the less useful esoteric one, and just present you with a finished solution for the other one. The first component to this solution is that deployers can actually set filters in saws. If I put a plank in here, it now sets the filter to be an oak plank. If I set a spruce log in here, it sets the filter to be a spruce log. And you can use this by not only shipping an ingredient item inside of your package, but also a renamed item that is then going to become your filter for the saw. And the way that I've done that is these 2 packages here are an example each. If I unpack this one, you can see that there is a filter renamed ladder in here and 8 andesite alloy. And the other one contains a shaft and again 8 andesite alloy. I can throw these 2 into this machine here, and you can see that it's making ladders because it managed to process the ladder package first. And very soon, now it's making shafts because now it's working on the shaft package. You can just use these attribute filters here. Let me just very quickly... So this filter here is just set to any item that has the custom name filter. And there's another filter on this one that is set to deny any item that has the custom name filter. And what happens in the machine is the package is sent to the packager, it is unpacked into this vault here, from where we send the named item up into this water stream to be pushed into this other funnel here, which then populates the deployer with our item to set the filter in the saw. We then also use this threshold switch to detect when an item is inside of the deployer, to then turn off the threshold switch, which will enable this belt funnel and pull all of the ingredient items that are still in here out of the vault, over the saw, and into your output to basically release the item from the deployer through this funnel. When the recipe is done crafting, we use this smart observer here to monitor the belt, and once the belt has not had any items on it for a while, we will shortly unlock the andesite funnel and also send a signal over here to re-unlock the input for the system, because the system will actually break if more than one recipe is trying to craft inside of this at the same time. So what we do is, as the item is spat out here into the water stream, we detect that with the smart observer and lock the hopper by pulling this redstone block across. And that means that no more items can enter the system until we unlock it by basically pulsing this funnel and unlocking the funnel down here. And that just makes sure that, as I said, no two recipes in here are crafting at the same time. The way you would set the system up with the crafting process is that you have to add 2 ingredients now instead of 1. So one of them is your actual ingredient for the recipe, and the other is this renamed filter item, which is now something that you have to have stored in your system somewhere for this to be able to craft, which also means that once you run out of filter items, because all of them are caught up in a crafting recipe somewhere, this will not be able to start a new craft until one of the current crafts finishes and returns its filter item back to the shared pool. But for create levels of production, that should usually be fine. Now, if you're okay with usually, this is probably the point where the video would stop being interesting for you. Because this solution is already very good for most cases that are sensible, but I'm not sensible, so I wanted a little bit more flexibility. And to do that, I started looking more at the way that addresses are actually processed in Create. Because if you've looked a little bit at the input and didn't just use plain text here, you might have seen that there is this star thing that you can use as a text wildcard. And wildcard usually means that if you put like a star in here, this will accept any package with any name. But this tooltip here is actually a little bit misleading, or I guess not misleading, but it's underselling what this thing can actually do. Because the system behind this star is way more complex, and we can abuse it to basically encode data in our recipe name. Now, short excursion into computer science here for a second. There's 4 rules that I could find that this system implements. There might be more, but these 4 are already enough for most of the stuff that I want to do. The rules are basically represented by special characters, and the first rule is any amount of characters represented by the star, any one character represented by the question mark, a range represented by these brackets, and sort of alternative strings which are represented by these braces and a comma-separated list inside. Any character basically matches 0 to infinite characters that are unspecified. Any one character also matches without caring what the character actually is, but it specifies that there has to be exactly one character. Ranges are specified by these brackets here, and basically any character inside of the brackets is a valid match. You can either specify them like this, where you explicitly mention every single character, or like this, which this is a range. So A through C. This is inclusive, so A and C are both still being matched. And this is sort of a shorthand for notation that saves you from having to type out every single character. And these alternative strings here are basically just every single entry in this comma-separated list is valid for that string. So this would match either high or by. And the way that this sets itself apart and also kind of stops being useful for us is the fact that it matches entire sequences of characters and not just single characters. These single character rules are more useful for us in our application, but this is still neat to know. Maybe someone has an idea on how to use this. Enough theory, let's do a little bit of practical just demonstration here, because one picture says more than 1,000 words or something, and I'm recording at 60 FPS, so that's a lot of words. So the setup here is we have this packager with a sign next to it where I can set an address. We have this frog port that will serve as our sort of demonstration whether the package passes the name filter or not. First, I'm going to demonstrate the question mark wildcard because that's the easiest one. This will match address because the question mark specifies that there is one character in front of ddress and there is one character in front of ddress, so that matches. It would also match bdress. Same logic here. It does not match dress because there is no character in front of ddress. And address also no, because there's more than one character in front of ddress. The star would match these last two ones. So it matches address because there is an arbitrary amount of characters in front of ddress, and just ddress as well, because arbitrary amount of characters can also be 0, and of course 1 as well. You can use both of these anywhere within a word. For example, I can use an expression like this to specify that my address has to start with a D and end with an S. So, for example, a word like dinosaurs would be matched for this because it starts with a D, it ends with an S, and anything between we don't really care about. The inverse is also true. We could match for anything that contains an E, let's say. So we have an arbitrary amount of characters in front, then an E, then an arbitrary amount of characters in the back. And of course dinosaurs, no E in there, so the frog doesn't care. But if we... it matches. What? Let's talk about the ranges next, because ranges can integrate with this very nicely. I'm just going to expand this example here to look for capital letters as well. So if I am a little bit excited, but this still should detect it, you can use ranges for that, because you have an arbitrary amount of characters in front, any of the characters in the brackets, and an arbitrary amount of characters in the back. And this string matches that. We have arbitrary amount of characters in front, a character that is within our brackets, and an arbitrary amount of characters in the back. And just to showcase the ranges as well, if we want to filter for any alphanumerical character, be it lowercase or uppercase, we could use something like this, because you can use multiple of these shorthand notations inside of one range. If I type some numbers, this isn't matched, but as soon as there is a character in there, that is matched. If you put an exclamation mark in front, this will invert the range. So this would listen for anything that's not in the range. So if we remove these, yeah. So this will basically match any character that is not a letter. I probably didn't mention this before, but if you want to use a star as a character and not as a wildcard, you have to escape it using \. This would match a star explicitly, but not an A. So if you see a character with a \, in front in one of these expressions, that is not a wildcard anymore at that point, that is a genuine character. And for the alternatives, I'm literally going to just copy the example from the board, because I don't really feel like coming up with a neat way to tie that into the narrative. This matches high, matches by, and it doesn't match a logo. Cool. So next step, how can we use this to store data? The frogs aren't the only thing that can evaluate these expressions. There's also this thing called a package filter, and that is basically a filter that can also evaluate these globbing expressions. But the result is a filter that you can slot into any of the smart components that Create has. Basically, any of these are able to evaluate the package filter and then perform their action based on whether the packaged item that they're dealing with has the attribute in the package filter or not. And one way that you can use this, I've demonstrated it here. I've set up a frog that listens to any package addressed to test space pipe space, and then any characters that we don't really care about anything after that. And inside of these smart observers at the back of the belt are package filters that are constructed similar to this. Part at the front we don't really care about. Space, pipe, space, A, B, C, and D. If I just type the address in here, you can see that that package is coming to the frog, but it also detected that this was an A-type package. If I put a B in there and do the same thing again, you can see that it detects that this is a B-type package. This effectively allows us to attach metadata to a package without having to scale up how many frogs we need to pull that package off the line. If we're coming back to our saw or our fan example from before, what you could do is you could assign each of these blocks in front of the fan to one of these lamps, and you can say, okay, package type A is lava, package type B is soul fire, package type C is normal fire, and package type D is water. With that, you would have a general setup with a fan where basically the metadata inside of the package name determines what block is put in front of the fan. This is still kind of a concept that we haven't really exploited to the maximum, because one problem that we currently have is that for now we're only matching exact metadata strings at the end. Let's say that for an item like the mechanical crafter, for example, the mechanical crafter is kind of the final boss of this project. It has these custom shapes here that are not able to be encoded into the normal mechanical crafter integration with the packages. So these need custom handling. And one thing that would be really cool to do is being able to encode into the package what slots should be enabled or not. Because while in vanilla there's only 2 pages worth of recipes, a lot of the Create companion mods really love this shaped crafting. While in here, specifically building one crafter setup for each of these is still feasible, especially because this one's probably the only one that you actually want automated. In Create mod packs, it might not be. So what would be really cool is being able to encode which slots are locked and which slots aren't. To do that, we would have to, at least if we're working within the vanilla Create shape, we would have, for each of these 20 1 slots here, we would need information as to where it's enabled or disabled, which means 2 to the 21 possible variants for our metadata string at the back. And I'm going to put the number on screen on how big exactly 2 to the 21 is. I feel like even just doing the math in your head, you could probably tell that that is way too big to build in survival or in creative or in Minecraft just in general. So we need a better way to evaluate these metadata strings. I'm going to be talking about some of the sort of math behind complexity of each of the following approaches. And just as a benchmark, I feel like it's nice to include here that the complexity for this approach of just matching each thing one-on-one is growing by m to the power of n, where m is our possibilities that we have for each of our characters. So in our example before, our alphabet size would be 2, because we either have 1 for the crafter slot being enabled or 0 for it being disabled, and we have 21 slots, so our n would be the length of our character string. So to represent a crafter configuration, we would need a 21 long string consisting of characters that have 2 options each. And our goal is to cut down on this complexity. The first thing that we have to get away from is targeting the entire string at once, and instead targeting positions. If we could evaluate the first position, and then the second position, and then the third position, and then the fourth position, we would go from our original m to the power of n to a still insane but less insane m times n. So this one, we need to make m to the power of n package filters. And this one here, we need to make m times n package filters. So with this one, we need to check every single possible combination of characters. And in here, we check for the first character, we check every character in our alphabet, then for the second one, then for the third one, and repeat that however many characters we have in our string. And implementing this is where the question mark is such a cool feature, because to match the first character, that's pretty easy. We can just do an A. I need a cool name for this. Let's do Fox. Does Fox start with an A? No, it does not. Does Fox start with a B? No, it does not. And then eventually we would get to F, and it would match, and then we know that Fox starts with an F. For the second character, we specify that we want a single character in front without actually caring about what it is, and then we write the character that we actually care about here. Does Fox have an A in the second position? Yeah, this is now better than our original approach, but it's still not great. One way that we could improve this, especially for smaller bases, I'm going to be working mainly with base 16 because hexadecimal is nice to work with. What we can use is basically converting a character into its binary representation and then filtering based on that. We can filter by representing our character as a sum of these 4 numbers and then looking at whether a certain number is present in that sum. So, to example, to see whether 1 is present in the sum, we can do we have all odd numbers, so that's 1, 3, 5, 7, 9. B, which is a placeholder for 11. D, which is a placeholder for 13. And F, which is a placeholder for 15. Because in our number system, 11, 13, and 15 are 2-digit numbers, but in hexadecimal that would still be 1 digit, so we start using the letters. We have 6 in a string, and we want to evaluate what representation in this system we have. Then we can first check if 6 has the 1 in its sum, which it does not. We can then check if 6 has the 2 in its sum. So, checking that, we have now determined that whatever is in here is 2 plus 4, which is 6. And we have done that by using 4 checks instead of the whole 16 checks that we would theoretically need to check every single character in this alphabet explicitly. And the complexity for this is that we go from m times n to log 2 of m times n. Log 2 of her alphabet size is how many checks we have to do before we can narrow down what character exactly we're dealing with. This is already a lot better, but still room for improvement because we still scale linearly with the length of our string. We would like to get rid of that somehow. Now, to actually do that, we have to use another feature that Create presents us that I'm not sure if it should be used in combination with this, but it's really cool and it can solve our problem very deeply. That's the display link here. For anyone who doesn't know, display links have a sort of menu that you can select from what you want to display in stuff like Nixie tubes and signs and display boards. And what these can do when connected to a smart observer is they can read package addresses. So if I write a package here that has the address hi, put it on there, you can see hi appears here. And signs, which is what we use to address our stuff, are a valid target for the display link, which means that we can copy the address from one package to another package. But what we can also do is use that in combination with this attach label feature here. And what that basically does is it appends whatever is in here, followed by a space to the beginning of what would normally be put on this. So right now there's hi. If I put just an A in here, you can see that we've added an A, a space, and then hi. Now, a quick example of why that would be useful is this system here. This is a 2-component system. Each of these sides of the chain conveyor is one separate actor in the system. You can ping this side, and it will then send a response back to you specifically. The reason why this could be useful in normal create is that you can see that we explicitly have to specify where the results of our saw crafting go. So if I wanted to use this saw crafter between multiple storage vaults, what would basically have to happen is I would have to be able to identify which vault the items came from, so I can then send them back to that vault. And the system that I'm about to showcase allows you to do that. So what we first do here is, I'm going to just quickly explain the protocol here. This is the intended receiver of our initial message. And back here is the name that we ourselves are going to be listening to. So in this case, we are sending a message to ping, but we are sending it as Fox. So I quickly do that, and it'll go into this frog, which matches everything that begins with ping. We then use this display link to write the package address onto the sign, but we also add this RE in front, with which RE is short for return. And once we send this, it'll match this frog over here, which is set to accept anything that starts with RE, has an arbitrary field in this position, and then has Fox. So any package that was originally sent by us and is returning will be sent back to us. So in the case of the crafter, this would be our ingredients. It would be sent to the saw. The saw would save the data somewhere. Once the result is complete, it would send out the packages with this address, which we can then listen for and grab ourselves. And now the question, of course, is how do you actually store this data over longer term? These display links can be disabled using Redstone, and they will only send updates as long as they're enabled. If I take this off now, I can theoretically destroy this package, which gives me a bunch of brass casings. But you can see that the text on the sign is still here. And it will stay there as long as this lever stays on. If I turn it off, it'll disappear. But hold on, Fox. You said we want to read data. What you just did is write more data that we still can't read. Kind of, but not really. See, what we did just now is we appended things to the start of our string. And we can use that to actually evaluate the entire string using a single set of package filters. We are reading this portion of the word. So from the start of the word, that's the 5th character. We can evaluate this by using 4 question marks and then doing the binary bit checking pattern that I elaborated over there where I was at the frog. And what we can do to evaluate this character here is add something to the front of our string, because relative to the front, this is now the 5th character. But relative to our original word, what we've just done is we read the 4th character. And if we add more data to the front, we will now look at the 3rd character. And we can basically add data in front until we have shifted everything that was originally to the left of this character that we're looking at. We can shift all of this over this position and read from it. And that eliminates the linear component in the formula that I had before. If you remember, the original formula was log2 of m times n, and we have just eliminated this n here. We have allowed a single set of package filters to address any character in this string, which means that the length of the string doesn't actually matter anymore. We don't have to add more package filters as our string gets longer. And of course, the only logical conclusion that comes from this is this thing here, which is a hexadecimal package name decoder. I'm still working on the name. What it basically does is you have this package here that has a name, and what we can do is we can put it inside of this barrel here, and what it will happen once I click this button is that it'll be dispensed out onto this belt. It'll be running next to all of these 8 smart observers, and wherever a smart observer detects that the package filter that it is holding is matching the package address, the piston underneath this red and green block will trigger, and the block will be pushed up so we can read from it. Basically, the block being in this up position, like this one here, symbolizes a 1, and the bottom position symbolizes a 0. And the reason why we read 2 characters here is that, as I showcased in the portion where I introduced the package reading combined with the label, the minimum amount that we shift is 2 characters, because create always adds a space at the end of our text. So to shift by 1, this label would have to contain 0 characters. But if the label contains 0 characters, then create doesn't add the space. So the best that we can do is shift 2 characters at a time, and then read them in 2 positions. So what we are actually doing, to represent it in this example, we are reading both of these, and then, so we're reading the 4th and the 5th character, and then every step we add 2 pieces of data in front. So these 2 are now these 2. Alright, enough talking, let's actually see this thing in action. If I press the button, you can see the package is running across. And it had correctly decoded that the last two letters were C and D. And what this part over here did is it added an underscore to the package name. As I already said, this is 12, 13, 11, and 10. We then have 9 and 8. And finally 0 and 1. And now we have read the entire string in the package and converted it into data that we can work with on the Minecraft level. Sadly, the length of data that you could put in here is limited. The UI inside of package filters is limited to 25 characters. This here is what our filter looks like. Because we're working with hex digits, we have to include half of our alphabet inside of the ranges here. And then we also have the brackets to say that it's the range. We have to specify that we don't care about anything after that. And anything apart from that can be question marks. But there is not an infinite amount of question marks that we can put in here. Our position that we can start reading from is limited by the amount of question marks that we can put before we run out of characters. In this case, after 5 shifts, we would start reading the dummy data that we put in front to actually start shifting all of these, which of course doesn't hold any informational value for us because it's not determined by the sender of the message. It's determined by whatever character we decided to put in there. There's also this really interesting sort of optimization problem here, because of course if we make our alphabet bigger, we need less question marks to represent our data, because one single character can hold a larger informational value. But at the same time, making our alphabet bigger takes away from the amount of characters that we can have in our string. So with a very large alphabet, we can have very few characters, but they're informationally very dense. And on the other hand, with a very small alphabet, we can have a lot of characters, but individually they don't hold much weight. And I believe there is some sort of sweet spot here where you can maximize the amount of data that you can contain in the string, but I didn't really care much to find it because honestly, hex is good enough. And it's actually easier for me to think in hexadecimal as a programmer than coming up with some esoteric base 23 system that is mathematically perfect, but just isn't very nice to work with. Another quirk with this system, with this one, is that to use it together with addressing the packages with frogs, you probably want to put the metadata in front of the address. And the reason that I say that is that this approach here is more robust to variable address length names. So if you remember, we are working with the fact that from the start of the string, we are reading the nth character. And if we have a variable length name in front, the nth character could be this one, but it could also be this one if we have a longer name in front. And you might say, okay, we'll just make it a fixed size length. You can just add a couple spaces and then that's okay. The problem with that is that you have to explicitly ignore each character with a question mark, because we can't use the star wildcard because that makes us lose our ability to specify the position inside of the string that we want to evaluate, which means that we have to basically blank out the address name with question marks. But as you might remember from the comment before, the limiting factor for the amount of data that we can store is the amount of question marks that we can fit before our filters. So now, with the address in front, the address itself is taking up valuable space. The frog that needs to pull the package off of the line doesn't actually care about the data, it just cares about the address. So what we can do is we can put an anchor character here, like the space pipe space sequence that we had in that example over there, and then just start writing the address here. And the frog can match that without problem. But our valuable space that we can read into using this trick is not compromised by that. So that was my insane ramblings on encoding data inside of package names. I hope you enjoyed it. I hope you could follow it. I hope this has maybe inspired you to do some insanely cool stuff that I didn't even think of. If you found this useful, feel free to use it. And tell me about what you did with it. Yeah, you're right. I don't need an outro.